All right, now we're actually going to do an example of computing standard deviation. And this is pretty easy. It's going to be a recipe for you. Let's go ahead and give it a try. You have the following observations in a given sample. All right. You can't see this, but I'm changing all these numbers on the other side of the screen, and I'm clicking on the wrong screen. But the numbers that we are dealing with are 1, a 9, 5, 8, and 7. It's easier to place them in a table than just leave them sitting out there on the line. So let's go ahead and do that. So my X scores are 1, 9, 5, 8, and 7. And so let's go ahead and compute the mean. How do I compute the mean? We've done this before. We take the sum of x divided by the n. So we take 1 plus 9 plus 5 plus 8 plus 7 and divide it by 5, and that equals 6. That's the mean. Step 2, we need to compute the deviation score for each value. Don't forget, this is just like a recipe. So we're going to subtract m from each x. Let's go ahead and do that. The first x is 1, so 1 minus, what was the m that we just computed? It was 6, so we're going to deduct 6 from each of the x scores. So we're going to go ahead and say 1 minus 6 equals minus 5, 9 minus 6 equals 3, 5 minus 6 equals minus 1, 8 minus 6 equals 2, and finally 7 minus 6 equals 1. Pretty easy so far, right? Step 3, we're going to square each deviation score. Okay, so we're going to take that score and we're going to square it. See that little exponent up there? We're going to square it. So we take minus 5, and minus 5 times minus 5, what happens when we multiply two negative numbers? We get a positive number, and as a matter of fact, squaring removes the sign, so these are all going to be positive. Minus 5 times, negative 5 times negative 5 equals 25. 3 times 3 equals 9. Negative 1 times negative 1 equals 1. 2 times 2 equals 4. And finally, 1 times 1 equals 1. Why are the standard deviation scores squared? Because the sum of squares is the sum of a squared deviation. And the distance can't be negative. Okay, so we got to get rid of these negative numbers. So, as I said, squaring gets rid of the negative numbers. Step 4. Sum the squared deviations to obtain the sum of squares. Wow, that's pretty easy, right? So we're going to look on the bottom here. The sum of squares is we're just going to add up my squared results. So we're going to add 25, 9, 1, 4, and 1, and that equals 40. The next thing we're going to do is compute the variance. So there's my table, and the variance equals the sum of squares divided by n minus 1, because this is a sample, not a population. So we're taking that, and we have 5 observations. We're going to take 40, which is the sum of squares. We're going to divide it by 5 minus 1, which gives us 4, and that equals 10. Okay, so because 40 divided by 10 is 4. And step 6, the last step in the computation is we're going to compute the standard deviation. How do we do that? A little s equals the squared root of the variance. So we're going to take 10, that's the variance that we obtained in the last slide, and we're going to, here, I'll pull up my little calculator and just drag it over. So we're going to take 10, and we're going to hit the square root, and it's going to come up to be 3.1622. 3.16, and of course we're only going to use 2 numbers here, and I hope you could see this little calculator. And that is the standard deviation. So we just computed your very first standard deviation. Congratulations, you did a great job. And let's take a look at where we're going next here. You have the following observations in a given sample. Here's another one: 2, 4, 6, 5, and 8. And don't forget, we're going to not leave them on the line. We're going to place them in a table to make our life easy. So there they are in a table, and we're going to compute the mean. That's the first thing we do. So how do we compute the mean? Don't forget these 6 steps. They're like baking a cake. We're going to take sigma, which is the sum of x, and divide it by n. So we have 5 observations. We're going to add these up and divide them by 5, and that equals 5. And step 2 is compute the deviation score. So here we go. We're going to take x minus m. So we're going to deduct 5 from each one of the scores. So we have no negatives in here, so we don't have to worry about negative numbers. And we come up with values of 3, 1, negative 1 rather, 1, 0, and 3. And now we have a couple of negative numbers. And here's what we're going to do. We're going to square each deviation score. So there you go. What are they going to do when we square them? It's going to get rid of the negative numbers because we can't go and have a negative distance from the mean when we're computing a standard deviation. So negative 3 times 3 is 9, negative 1 times negative 1 equals 1, etc., etc., etc. And let's jump to the next slide to do step 4. We're going to sum the square deviations to obtain the sum of squares. So we're going to add the numbers that we just computed up right here, and 9 plus 1 plus 1 plus 0 plus 9 equals 20, and that is the sum of squares. And you remember the next one, we're going to compute the variance. Okay, the variance is the sum of squares, and this is a sample, not a population, so we're not going to use big N. We're going to use little n minus 1. Okay, so the sum of squares is the number we obtained last time. The sum of squares divided by 5. I'm sorry, actually 4, because there are 5 observations, and it equals 5. So 20 divided by 4 equals 5. And the last step is we're going to compute the standard deviation. So we're going to take the variance, which was 5, and we're going to take a square root. So let's get our calculator over here. We'll drag it over. We'll put 5 in, and we'll touch the square root function and find out that it is 2.236. When we round it out, it's going to be 2.24. And we just computed your second standard deviation. Congratulations. If we're doing it for a population, it's the same 6 steps as for the sample with 2 small differences. Different symbols, and the population mean as opposed to m in the sample, and population size big N as opposed to little n in the sample. Population standard deviation is going to be a small sigma as opposed to an S, okay? And don't forget, variance in a population equals the sum of squares divided by n, not n minus 1, as in the sample. So I want to talk real quickly, and I hope I'm not running out of time here, about the empirical rule. When we look at a normal distribution, this is really neat for cocktail parties, so remember this. 68% of all scores are expected to fall within 1 standard deviation of the mean. So we could say that if standard deviation, if the mean IQ score is 100, 68% of the scores are going to fall within 1 standard deviation of that mean. So 68% of the population is going to be within 1 standard deviation of the mean IQ score of 100. Now, look at this. 95% of the scores are expected to fall within 2 standard deviations, 1.96 of the mean. So 95% of the people are going to have IQ scores no less than 2 standard deviations less or 2 standard deviations more than the mean. And 99% of the scores are expected to fall within 2.5 standard deviations of the mean. So what we're looking at is what's the standard deviation. So and that's what we just figured out. And depending on the distribution and the shape of the curve, platykurtic or leptokurtic, we're going to compute that standard deviation and tell a lot from the numbers we get. We're going to be able to tell, geez, what's really out there? What's 3 standard deviations or 2.5 standard deviations away on the upside of IQ is really smart. Whereas 68% of the population is going to be within 1 standard deviation. So take a sample of coffee drinkers, okay? M equals 7 cups and S equals 2 cups. All right, so here's another example. Take a mean of 4 beers an hour with a standard deviation of 1. All right, between what range of number of beers would you expect to find roughly 68% of the cases? All right, so take a look. A mean of 4 with a standard deviation of 1. So I would say that between what range of beers, so I would say 1 less and 1 more. So between 3 and 5 are going to be 95% of the cases. Go back to the empirical rule and see if you could remember that. And 98% of the cases, 2.5, about 2.5. Okay, and I think that we are pretty much all done. And what we'll do now is go compute some standard deviations in SPSS. Thanks for your attention, and if you have any questions, let me know.